All right, good morning, everybody. So, I had an idea for a video here. Actually, I'm working on these samples, and I thought this would be something really useful to document and share. So, I'm on the Helios Nanolab 600i here, and I am preparing lamellas from a specimen which has a very textured surface. Okay, so this is the SEM image over here, and this is a silicon wafer, 001 wafer. It's been chemically etched, and depending on how you etch it, you can get these pyramidal structures, and you can see the scale bar here. So these are, like micro scale, okay? And so on top of this wafer, there is a series of thin film coatings. And so this is what we want to image with STEM, okay? So we want to prepare a lamella from this. So obviously as part of that, we need to put down, PT strap. So there's some additional considerations for doing this when you're working with a rough surface like this. So the way that the lamella is going to be cut here is actually, if we look at this one here, so we're going to actually cut left to right like this. So basically the normal surface, or the normal direction to the cut direction, is going to be equivalent to the normal direction to these pyramid faces projected onto the nearest in-plane direction, which in this case would be a 110 direction. So anyways, the lamella is going to be cut like this, okay? So this provides some challenges as far as doing the platinum deposition, okay? So, and the reason for this is, if we do the strap like this, so okay, so if we do the strap like this, we're going to have some problems here with what's called line of sight, not with the SEM beam. So I'm in the SEM right now, of course, and I'm at eccentric height, and so this is 0 degrees tilt, so we're looking straight down on the surface. So we don't have an issue in terms of line of sight with the beam, but where we have an issue is actually with the flux of the precursor. So if we let me just quickly check the height here. Actual. Okay, so we're pretty close here to eccentric. So on this system, let me mag out here so you can see this. Okay, so the platinum needle comes in at kind of a 45-degree angle, at least when it's projected onto the projected direction onto the surface, okay? So the flux is directional, right? The flux is not, top down like we're seeing with the SEM beam, okay? So if we were to do the deposition right now, we probably aren't going to get even deposition across the surface, okay? So what we need to do is we need to rotate the sample 45 degrees, and it could be, counterclockwise or clockwise. It doesn't matter because of the symmetry of the sample here. And again, that's a relative rotation. And then we're going to do the same thing with this pattern, okay? So we're going to rotate the pattern here like this, and we're going to rotate the stage by the same amount, okay? So let me go ahead, I'll leave this here. Let me take out the GIS, and I'm going to do a relative rotate by 45 degrees. You want to make sure you have compucentric checked here. That's going to keep this feature in the field of view when it does the rotation. And so you can see now when now I have better alignment, or I should say better line of sight for doing the deposition onto these surfaces. Okay, so now I need to find a good pyramid here for this. I think I was probably going to use this one before. That's not terrible. Let's see if there's maybe a better one though. This one might be a little bit more open here. Decisions. Okay, we'll go with that one. That looks a little bit better. All right, so stage is rotated, pattern's rotated. I'm gonna change my conditions here. And now I normally put down 1/2 a micron, but what I'm gonna do is I'm gonna put down 1/4 of a micron, and then after that, I'm gonna do a relative rotate of 180 and do the other 1/4 micron the other way, okay? Because even though in principle we have better line of sight here, I feel that's gonna give, with something like this with a topography, that's just gonna give a little bit better result. So we'll go ahead and insert the platinum. And so now you can see the geometry here. So we have the flux coming in with more optimized line of sight here. Let me remove the center cross. Okay. Open up the flow here. So for doing PT deposition with the SEM beam, 2 kilovolts is considered optimal for this. And really there's no penalty as far as, it's not the same issue you have with doing ion beam assisted deposition where you have to keep the current density, from being too high. With this, really, you could go as high as you want, and that's gonna, enhance your deposition. The trade-off is your beam is bigger, so your deposition is not gonna be quite as precise. But we're not trying to be super precise here anyway with doing this strap here. So, all right. See if I can, there we go. All right, and we'll go hit play. So again, once this is done, feel free to fast forward, 2 minutes ahead of time. I'm going to do a relative rotate of 180 and deposit another 1/4 of a micron on top of the original one, okay? Just to ensure that I'm kind of getting it from both sides. And then we'll talk about the considerations for doing this with the FIB beam. So with the FIB beam, it's kind of a similar situation, but we have to do some additional manipulation to the stage because of the geometry of the flux relative to the FIB beam. Okay, obviously we're going to tilt to 52 degrees for doing that. So we're normal to the surface as far as the beam is concerned. So actually what we're going to do once we finish this strap is we're going to relative rotate by 90 degrees for when we do the FIB assisted deposition. So just to show you here, because I actually took some images of this. Let me see here. Let me clean this up really quick. Oops. Okay. What did I do with that? Okay, let me open this up. Oh, actually, I won't be able to open it up on here anyways because this is running Windows XP and I can't open 16-bit tips in it anyway. Anyways, with the FIB, I've got the scan rotation here at 180. That's what I typically use with the FIB. Again, I know that's kind of a matter of preference, but we saw the PT GIS come in from the upper right corner, in the SEM, it's going to come in from the upper left corner in the FIB, again with a scan rotation of 180, okay? So we have to kind of keep that in mind. All right, how are we doing here? Oh, we're done, okay. All right, so there we go. And so now we're gonna pull this out and we're gonna do a relative rotate of 180 now. And hopefully we'll be able to find, now I don't have enable safe stage moves checked. The reason is that we're at 0 degrees tilt and everything is flat, but if I was tilted, I would have enable safe stage moves activated. But I'm just, I'm leaving that off now to help expedite. Okay, so here's the strap here. So our compucentric rotation alignment, pretty good. Okay, we'll go ahead and put the PT back in. Obviously at 2 kV and 11 nanoamps, our deposition, or I should say our SEM image is not going to look super clean, but again, we're not trying to be super clean here. We're trying to put down PT strap. Let me see if I can't stigmate this a little bit better. Okay, looks about as good as we're going to get it here. Okay, we'll go ahead and do that. And this will complete the PT, or the SEM-assisted PT deposition. And so once this is done, I'm going to do a relative rotate by 90 and then tilt to 52, okay? And I will, I'll show you why. Once this is done, okay? So actually, well, let me see if I can't maybe save this as a PNG and then open it here. I'd rather not, well, again, if I'm at low enough current. This has a protective coating on it already, so I can, it can take a limited amount of low current, wide field of view ion beam exposure without, damaging the surface. So it's probably the easier thing to do. It's going to show things a little bit better. So this strap is 20 by 3, and so when we do the FIB deposition, our FIB current is 300 picoamps, and so if you do the math, that gives you a current density of about 5 picoamps per micrometer squared, which is optimal as far as FIB-assisted deposition is concerned. This is a gallium source, so there's no need to use a voltage lower than 30 for doing this, unlike the PFIB. And in an ideal world, right, we'd have the precursor flux would be in the same direction as the beam, but obviously that's not possible because then the GIS would be occupying the same space as the beam, and obviously that's not physically possible. And of course, this is irrelevant if we have a nice flat wafer surface, or of course, right, this isn't even right if you're just trying to make a cross section for like in situ SEM imaging. Same kind of considerations, right? This doesn't have to be related to lamella prep. This could just be doing cross-sectional imaging. Okay. So let me delete this. And now we're going to do a relative rotation of 90. Okay. going to tilt to 52 degrees. So you can really see here how rough this surface is when I tilt the stage. Okay, so these pyramids are very, very, well, I shouldn't say they're rough, but there's a lot of height variation here, right? You know, like 10, 20 micrometers, okay? So this is obviously, you know, challenging just in general for, you know, making lamellas. Okay, so actually, let's start by just, yeah, we'll unpause here. Okay, so we can see the strap right there. And so notice how the strap is oriented like this. So I'm gonna actually pause this for a second, and I'm gonna drop the current down to 10, just so we don't cause as high of a dose here when I mag out. And let's put in the platinum. Okay, so you can see there's the GIS. So that's coming in from a 45-degree angle approximately relative to the upper left corner now, again with the scan rotation of 180 on there. Okay, so now again, same idea, right? Based on how the flux is, because it's coming out of the GIS, and of course this is inclined relative to the surface. It's not, you know, it's not parallel to the surface. Obviously that wouldn't be good. You'd want it ideally, you know, normal to the surface, but again, I already specified why that's not physically possible, because the beam is already occupying the space. But yeah, that's the geometry here, okay, to ensure more optimized line of sight. Okay, so we'll go ahead and switch back to 0.3 nanoamps. Okay, open up the flow. Draw our pattern here, 23. Now I'm gonna do 3/4 of a micron, and then I'm gonna do relative rotate 180, and then do 3/4 of a micron the other way. So now this has to be minus 45. Okay, looking good. And there we go. Right. So yeah, I wanted, you know, I made a sample from this yesterday, and then I realized like, oh, this would be a great video to do. And I thought about, and then I'm like, well, I only have, I only have use of one of my hands completely. So, you know, I realized I was going to need help. So I've got the tripod here holding the camera, or the phone, I should say, to facilitate this, because it wouldn't really be possible otherwise with my my current state of temporary disability. But yeah, this is just you know, some ideas here. If you're working on surfaces that are rough like this, or that have a lot of topography, to help get more even deposition of your protective straps. These are, of course, you know, this very challenging to make lamellas from a surface like this. Although I was able to do it yesterday to get something that should produce a good result. All right. Okay, so you can see it going down here. But yeah, you can see just how rough this is. I mean, this is not a, you know, a nice flat wafer by any stretch of the imagination. You can kind of see it down here. Let me go to full frame. Okay, so this is the CCD quad. So here's the the FIB column. That kind of cut it off. No, it didn't. So here's the FIB column. Here's the GIS right here. So this is actually coming in at a fairly high angle relative to the in-plane surface direction, which is good, right? Ideally, you'd want that angle to be 90 degrees, right? So it is coming in at a fairly high angle, although it's still, you know, not 90 degrees. So you're still going to have some potential line of sight issues when you have a rough surface. So that's why that's why you can do this trick with the rotation. And again, like I said, I'm going to do the relative rotate here to do the other 3/4 of a micron deposition to get the total thickness that I'm shooting for. And then once the strap is done being deposited, then I'm going to rotate so the strap is horizontal in the SEM image, and proceed from there with making the lamella. So it's always it's always useful to, or I should say, stimulating to work on samples like this, because it helps you kind of problem solve and think outside the box with certain things. Although I've had to deal with issues like this before with high topography features on surfaces where people have wanted cross sections made of them. So this isn't the first time I've dealt with something like this. All right, let's take out. Now I'm going to do a relative rotate, and because the stage is tilted, I'm going to enable save stage moves, and we'll do a relative rotate of 180. So the rotation axis is always, in this case, it's going to be perpendicular to the, or I should say normal to the face of the stub, okay? The rotation axis doesn't change regardless of how the stage is tilted. So keep that in mind, right? That is fixed. All right, we're going to do relative rotate of 180. All right, and we're pretty accurate here. Okay, switch to the, okay, looking good. So we'll put in the platinum. Open up the flow to give it a minute. Okay, it looks good. And there we go. So with the this sample in particular, I'm concerned. I'm trying to get a good, or the, I should say, well, you can kind of see it better here in the FIB image. So I'm actually trying to look, like I said, at these pyramid faces, because those are flat. So So there were two of these samples I was working on. One of them actually has far worse or more severe topography than the other one. This is the one with the more severe topography, actually. So, although the geometry of the pyramids is the same, right? I mean, the angles don't change, so there's really no difference there. Yep, there we go. So I believe if we do well, it'll be easy to figure it out because we'll either guess right or wrong. I believe if we do a relative rotate of -45, that should put the strap horizontal in the SEM image as well as the FIB, because again, the FIB is scan rotated 180. And that's the last thing I just want to show you before we call the video quits. Definitely much easier with this tripod here. Just a little bit more left. Okay, take out the platinum and I'm going to tilt back to 0 and then do the rotation because I'm going to check the height. Looks like we're relatively close. Okay, I had stage moves checked, that's fine. Just gonna take a little bit longer. Oops, okay, so I guessed wrong. All right, no problem. So now we just do a relative rotate by 90 and we will get the right orientation. And I'll turn off enable save stage moves here. There we go. All right. So we're all set to finish with the rest of the lamella prep. So that was what I wanted to share with you. Just some tips and tricks about doing PT deposition in your dual beam when you have rough surfaces. So hopefully you found that useful. And take care, everyone.